Welcome to my channel Code with Fernando. Let's continue with operators. Operators are special symbols used to perform operations on variables and values. Understanding the different types of operators and how they work is essential for writing efficient and effective code. Operators in Java can be grouped into various categories, such as assignment, arithmetic, relational, and logical. Assignment. We use this to assign values to variables. Then we have arithmetic. We perform basic mathematical operations like addition, subtraction, multiplication, division, modulus, increment, and decrement operator. Then we have relational, compare two primitive values to determine relationships, such as greater than, less than, equal to. Then we have logical, apply not and or logic to primitive. Assignment operators are used to assign values to variables. The most commonly used assignment operator is equal, but there are also shorthand assignment operators, like these ones. Assign a value to a variable. Okay, this is the first one. Then we have, okay, let me fix this. It's kind of confusing. Okay, this shorthand means adds and assigns the result to a variable. This shorthand means subtract and assigns the result. This one means multiplies and assigns the result, divides and assigns the result, and finally computes the modulus and assigns the result. I know this looks really confusing, so let's continue our code demonstration. I have created this class called assignment operator demo. Inside that class, I have created the main method. There are two variables declared, one of value 10, the other one of value 5. Let's see the shorthand assignment operators in action. First one, we need to see this one. It goes like this. Addition. Okay, so it's like this. This means take the value of a and add the value of 5. We print this value of a, we'll see, okay, let's continue. The other one, subtraction. Take the value of a, subtract the value of b. Now we print the value of a, we get 5. Okay, let's continue. Multiplication. Take the value of a and multiply by the value of b. And we have 50. Okay, let's continue with division. We are dividing a and b, right? We will get 2. 2. Now, modulus operator, we get a remainder. Only the remainder. Don't forget that. So we're going to get 0. Assignment operators. When working with assignment operators, it's really important to remember the rules of data type compatibility. For example, we have a double, my double 10.2. Okay, double can store decimal because we have double and float if we want to store decimal numbers. Then we have in a because this is an integer. That's okay. Then we have a float. We can use a float to store decimal numbers using the f. It could be uppercase or lowercase. Doesn't matter. What is not valid? What are invalid assignments? Then we have we are creating a double in here, and we are assigning to a true value. We cannot do that because boolean can be assigned to double. Then we are creating a boolean value, and we are assigning a character. This is a single character. That's not possible also. Continue with our code demonstration. We are creating a variable of type double, name my double, very simple, assigning 10.2. Okay, this is valid, we know that. Then we are creating a variable of type int, my int will be just 10, and the other one will be a float. Okay, my float 10.5, but okay, we need to add the f here. Could be uppercase or lowercase. Okay, then we are going to print this to check the work. Okay, if we print this, we won't see any error. Okay, my double 10.2, 10, and 10.5. Okay, let's see what are invalid assignment. For example, let's create a double here. Let's create, this will be named my double 2. And we assign value of true. We cannot do that. We know. For example, okay, a boolean. Okay, my int. Let's assign value c. That's not possible because boolean can store only true or false. Working with assignment operators. While assignment is straightforward, some rules and pitfalls are important to note. Multiple assignments. You can assign multiple variables in one line. We have declared variable A with a value of 7, variable B with value of 10, variable C with value of 8, and we are assigning the value of C to B, then B to A. So all of them will have the same value, which means 8. Exam tip. Be careful with type conversions. You cannot assign values between incompatible types. Always remember to cast if necessary, but be aware of data loss when casting larger data types to smaller ones. Okay, let's continue with the code demonstration. Let's create three variables. Value 7, comma, then y value 10, comma, and z value 8. At the end, semicolon. Okay, now let's print this. Value of x, I'm sorry, value of x, and value of y, value c, y, and z. Okay, let's print this. We are checking multiple assignments. Should be before. Okay, we know that. Okay, now let's see the example of multiple assignments. Okay, let's take the value of s and assign that value to y. Then let's take the value of y and assign that value to x. So what is the value of s at the beginning? 8. So now s equals to, uh, we know that. Then the value of s assigned to y. So now y is also 8. Now value of y assigned to x. So now x will be 8. They all going to be 8. 8, 8. Okay. In Java, char values are stored as number. They're ASCII codes. When you perform arithmetic operations on char, the numeric values are used instead of character representation. So if we see this, we get the numeric value of a will be 97. So in the example, we see the ASCII value of a is 97. So adding a plus a, we get 194. Now, subtracting. If we subtract a minus a, we get 0. Char supports all arithmetic operations like addition, subtraction, multiplication, division, and modulus. Char behaves like an integer in mathematical expressions. Let's see the example. Let's create a char variable. A. We know that its value is 97. Okay, now we are going to print the character A is. Now we are going to print the sum. Character plus character. Char1 plus char1. Okay, so we are going to get 194. And here we are going to print the subtraction. And we are going to get 0 here. Okay, let's print this. 194 and 0. Java automatically widens byte, shove, and shove to in arithmetic operations. If a long value is present, all values including in are widened to long. If float or double is involved, all values are widened to double. Some common mistakes. You cannot directly store the sum of two byte values in a shove without explicit conversion. Why? Because Java promotes the result of byte plus byte to in, which cannot be stored in shove without conversion. Okay, let's continue with our demonstration. Let's call this byte value and assign value of 10. The other one will be a shoved value and will be 20 shoved. The other one will be char. And let's make it a, because we can use this as a number. Okay, we know this value is 65. Okay, now according to this, we have a byte, a shove, and a char. Byte, shove, and char. We can store the sum of all these numbers in an in. That's what I'm gonna do. In, and we are going to say byte plus shove plus char. Okay, now we are going to print this. Byte value plus shove value plus char value. Okay, and we're going to print the result int. Okay, let's print this. 95. Now let's create a long value. A long value. Okay, this will have a byte value, this byte value plus a short value and long. According to this, if a long value is present, all values including in are widened to long. So there is a long value here. So all this result is going to be widening to a long. That's why we can see this. Now we are going to print this. Plus short value plus 100. And we print the result long 130. Let's continue with unary operators. We have increment operator and decrement. Increase or decrease variables by one, only by one. Okay, they work with a single operand. That's why they call them unary. These operators can be used in two ways. prefix and postfix. Okay, prefix. The value is modified before. This is very important to note. The value is modified before it's used in the expression. Next, postfix notation. The value is modified after it's used in the expression. So we're going to see an example right now. Okay, let's create a variable called a with value of 5, then a variable called b, and we're going to apply here prefix notation. Okay, so we are going to do this prefix notation. Okay, let's analyze what's going on here. First of all, in this line of code, value of a is 5. After that, it has changed. First increment, okay, first increment. So now this becomes 6. So the value of a now is 6 will be stored in here. So a is also becomes 6 now. If we print this, value of a, let's see that value of a, and we're going to print also the value of b. Okay, the value of a and the value of b. Okay, I don't want to print this. Okay, let's see this. They both are going to be 6. A and b are going to be 6. Okay, let's continue. Now let's declare a variable called x and value 5, and variable called y, and we are going to use this postfix notation. So what I'm going to do here, like that. So value of 5 is, I'm sorry, value of x is 5. Okay, so let's assign that value to y. So y is 5, and then the value of x has incremented by 1. Okay, so now x will be 6. So if we print this, we are going to see x, here x also, y. Okay, value of y will be 5 and value of x will be 6. Okay, let's see this in action. Value of x is 6 and value of y is 5. Okay, great. Let's continue. Okay, let's continue with another example. Let's declare a variable called p, value of 20, I'm sorry, 10, and another variable called q, value of 20. Okay, now we are going to store the sum of those values in here in a variable called result. Okay, but first, prefix notation, like that. Prefix notation. P, then postfix notation here. Okay, let's analyze what's going on here. And let's create another one. With result 2, and here we are going to be prefix. Okay. In here, what do we have? Okay. Increment first, right? Increment first. So P will become 11. Okay. And we add that. Okay. Q after that. So will be 31. Okay. Let's print this first. Result will be 31. Okay, I don't want to see this anymore. Let's also, okay, omit this. So we're going to see 31. Okay, let's continue with the other example. Let's go to here and okay, let's check. Increment first. P becomes 11. Then let's decrement first. Okay, Q becomes 19. So this becomes 30. 30. Okay, if we print this, result 2 is 30. Is result 2. We're going to say 30 in here. Okay,